video, I'm gonna show you the case when central limit theorem fails. So what's this famous central limit theorem in the first place? So this theorem basically states that if you take a sufficiently large sample size, the sampling distribution of your sample mean will be approximately normally distributed, no matter what kind of distribution you take. You take Poisson distribution, you take normal, you take chi-square distribution, or whatever. So if your sample size is sufficiently large, then the sampling distribution of your sample mean will be approximately normally distributed. However, in some cases, the central limit theorem might fail. So the Cauchy distribution is such an example. So because this Cauchy distribution doesn't have finite variance and mean, the central limit theorem fails. So having a finite variance and a finite mean is the most important assumption behind central limit theorem. So if you don't have those conditions fulfilled, then central limit theorem basically fails. So in this video, I'm going to also provide you with some R code, and also you will see how it really works. So for that, first I open an R file in here called CLT, and also I open a C++ file, and I'm going to write a very short C++ code via Rcpp package. So if you are not familiar with Rcpp package, I very much suggest you to have a look at it. It makes writing C++ code in R really easy because there are certain sort of syntactic sugars in the package. So anyway, so let's move on to our code. So first, let me load the regular libraries in R. I'm going to load, let's say, tidyverse. So this is one package, and also library by, sorry. The second one is Rcpp, okay? So having loaded the libraries in R, let's also set n as 30 and also number of samples as, let's say, 1000. So by the way, you might wonder why I'm using C++ function in here. The reason is that writing loops in base R is not effective. They're really slow. So that's why I'm using C++ in here. So first, let's write the normal distribution in here. I'm simply gonna say normal means it's gonna be, let's say, random norm. So like I'm taking random values from a normal distribution in R. So it's gonna be num of samples. Okay, let's take the mean as 0 and standard deviation as 1 over square root of n. Good. So if I look at this in here, so we'll get the value. Yeah. With the Cauchy distribution, I'm gonna put this Cauchy distribution. Okay. So for this one, I'm going to switch to our C++ file. So you don't have to write everything from scratch because there are certain header commands in C++. So what you want to do is to open new file in C, oh sorry, not C file, new C++ file in here. So I'm going to delete this commands in here as well. So do not delete this one because this is going to export your functions. So just copy those from here to your regular C++ and then delete this one, okay? Yeah. Okay, so we are going to write our C++ code in here, and I'm going to say numeric vector because this is going to be the vector type of output in C++, and I'm going to say distribution Cauchy. Okay, and then I'm going to put n in here. It's an integer type, and also integer number of, in here, number of samples within curly braces. Okay, in here I'm going to say numeric vector again. Numeric vector means, and then I'm going to put the number of samples in here, semicolon. So for now, so let's explain what's going on in here. So the output of my function is a numeric vector. So it's a regular vector in R. The name of the function is distribution Cauchy. The inputs are n, which is the integer type, and also the number of sample, which is also the integer type. So first I create the numeric vector of means, the mean values, and I put the number of samples in here. So this is one part. And then let's move to the loops. I'm gonna say for, and for, and also curly braces in here. So this is going to be like for integer I equals to 0 semicolon. I is less than number of samples, semicolon, and then we increment I by 1, and then within the curly braces, so we create our sample numeric vector. Let's say sample equals to R Cauchy, and then we put the number of observations, which is n in here. Okay, so our sample is just drawn from the Cauchy distribution, and the sample size is n. Okay, and then let's write okay, put it in here, double sum equals sum plus sorry, I made a mistake. Sum is simply 0. So this is the initialization of our sum values. And then I'm going to write an inner loop again for, and then let's put curly braces in here. So what I'm gonna do, I'm gonna say integer j equals to 0 semicolon. J is less than n, so which is the number of observations, and then we increment j by 1, and then within curly braces again our sum is gonna be sum plus sample, and then it's going to be j. Okay, sorry, we need to put a semicolon in here. So do not forget to put those semicolons, otherwise your C++ function will not be compiled. So in here, the mean, so means I, it's gonna be sum over n. Okay, so I simply take the sum n over n, and then it's going to be mean value in here, and then outside of this loop I'm going to return means. So this is all. This is all that I need to do. Okay, so having written my C++ code in here, so let's move to the regular R code in here. So what I'm gonna do, I'm gonna say Cauchy means, Cauchy, let's say means. Remember in here I define normal means, and let's say Cauchy means in here. It's gonna be Cauchy, sorry, first I need to call my function in here. Okay, I need to call my function here, and I'm gonna say sourceCpp, sourceCpp, cpp Cauchy distribution.cpp. Okay, it's compiled. So now I'm going to call it. Was it distribution? Let's go to the file. Distribution Cauchy. Okay, it's the distribution Cauchy. Okay, and then n, let's say, is our n in here, so which we already defined. Number of samples is number of samples that we define, and then okay, so if I run Cauchy means, good, so we get the results. So let's combine this Cauchy means and normal means in a tibble. Let's say tibble, let's say distribution normal equals to normal means, distribution Cauchy equals to Cauchy means. Okay, so I made a data frame in here. So let's plot them, okay, and see the difference. I'm gonna say ggplot, and then let's take x as distribution norm. Good. I'm gonna say geometric density in here. Then also let's put a min in here. Okay, so this is for the normal distribution. Okay, I simply used this distribution normal variable in here. So let's use this Cauchy one. Okay. Okay, you see, right? So here the distribution is obviously not normally distributed. So it's because of the non-finite properties of the Cauchy distribution in the very first place. Yeah. Okay, so this is pretty much what I wanted to say. I hope you have liked what I covered. If you really did, I suggest you to subscribe to my channel and also give a like. I'm also gonna put the C++ and also R code in the description of the video. See you next time.